In this tutorial, I'm going to show you how to import data from Multisim and from this oscilloscope. I've already saved a file. I've already saved a file here from the oscilloscope. It's right here in this CSV file. You want to save them from the scope as a CSV. It's the easiest way to import into Matlab. CSV, just as a note, let's take a look at this one really quickly. You can just double click it, open up with Excel or any spreadsheet reader. Okay. And you can see what it gives us. And let's just zoom in a little bit and take a look. So this first part tells us what's going on. X, channel 1, channel 2, start, increment. Okay, so what, and then we have sequence, volt, volt. So this is just a sequence. This is telling you which sample it is. So this just goes 0 through however many this gets through, 1202. Okay, so that gets down there. But then these are the actual voltages that we recorded. Okay. There's no time in this. Old scopes used to give us a time sequence here, and the new ones just give you this, and they give you these two values. At what time it started, 3 times 10 to the negative third. So it started at negative 3 milliseconds, and each time step is 5 times 10 to the negative 6th seconds, so 5 microseconds per step. Okay? And so that's how we're going to plot each one of these, is we have to figure out how to do that. So let's save that for a bit. So that's there. But the circuit that I built, and I built it in class in the lab as well as here, is I just have two 5.6 kilo-ohm resistors, a 2-volt peak, 1 kilohertz signal generator, and then I've just hooked it up to 2 channels of the scope. Okay, and so when I run this simulation, it gives me, you can't see here. Now you can barely see the yellow. You can see both the yellow and the blue. And I did the yellow and the blue because that's actually exactly how it shows up on the scope, is yellow and blue for those 2 channels. So you can see the yellow there, the blue there. And what we're going to do now is we're just going to save. So this saves our data. I've already saved it once, but I'm going to save new stuff. Yes, I'm going to save it. It saves it as an SCP file. And I don't know what an SCP file is. It's specific to Multisim. But let's just take a quick look here, and we will. Don't have a pause button anymore on this thing. Okay, so let me go and find that file. And you should be able to open it with just any. So here we go. Example.scp. We could open this with, I like Notepad++, but we could go up here and say open with, and it may give us some options here. Maybe. WordPad might work. Okay. And it did. And so it's just a text file. They've just saved all their data as a text file. Now this one has time, channel A and channel B, and a whole bunch of other stuff that's going on up here. Okay, and this is huge, by the way. This just keeps on scrolling forever and ever. It saved the entire time that we were running the simulation. It ran that. So great. So I've got 2 sets of data. I have this is from the oscilloscope, is the new file 1.csv, and the example SCP is from Multisim. So let's crack open Matlab. So I've got Matlab here. I'm actually going to use a free window. This is the command window. I've dislodged it here for educational purposes. We'll do a script here as well because it'll be super helpful. Clear off what I did before. Clear all my variables. Close all of my figures. Then I'll do a CLC. Okay. CLC just clears the command window. Okay. So what do I want to do here? Well, I'm going to use the magic button, okay? The magic button is back here at home. We can import data, okay? So heck, why don't we start with this one, example.scp. And this will bring up a dialog box from Matlab, okay? It's going to read that file. It's going to parse it. It's going to ask what everything here means. And we have to tell it the window that we want to load in. I don't want to load from all the way up here. I want to load down here from line 17 to the bottom, all 3 rows. And so I have to modify this. So be careful modifying it. But A15, okay. So when I do that, and we have, so that looks like all the data we want. MATLAB defaults to a table. Tables are awful in MATLAB. Don't use tables. I like to use either column vectors or numeric matrix. Okay, we're going to import this selection. Okay, a little window will come up that says successfully data parsed. It's an example. It's a 15631 by 3. Okay, so I'm going to close this. We're back here at MATLAB, and you can see example is a variable. And so if I go back to my command window, I should be able to look at example, and it's just going to spew off data for a long time. Okay, and it went a little bit long. You see those last 9 or the last 3 columns are NaNs. That's not a number, and so those are junk. We're going to ignore them. Okay, but what we can do now is we know that the first column is time. The second column and third column are channel 1 and channel 2, and so I just want to plot. Well, let's just I could just plot example. Colon means 1 to the end, so you could do 1 to the end, which is all, or I could just put a colon, and that tells MATLAB I want everything, and it's the second column, so row column. It's just like matrix stuff in other places. So plot this. All right, so it plotted it there. Well, that doesn't make sense. This ain't no good. Actually, it does. So I just zoomed in, and you can kind of see. You're like, ooh, ooh, ooh. It kind of looks like it. And so we have to use the zoom in feature. I hate MATLAB's new zoom in feature, but there it is. Okay, that's really good. Now, just so that we're clear on this, okay, I'm going to plot this. I'm going to add one more thing. I'm going to plot dots, okay, and you'll see the difference here. So that's kind of interesting, isn't it? It just plotted dots. Well, let me zoom in again, really tight here, and you can see what's going on. This will be helpful if you understand what you just saw. It'll be very helpful in your next class, which is signals and systems. And so each one of those points represents a dot, and what you're seeing is these were sampled perfectly because it was a simulation, and they all made lines horizontally. I still don't like that. I'm going to do a dash dot, or a dot dash. That looks even cooler here. Just having all sorts of fun in this. But you can see there's a dot, and it's interconnecting now with the dash in between each line. So that's what we look like now. And we have some data here. Now the only problem with this is if I grab this tool, the data tip, it puts the data on each tip, and I look at it. X is incrementing by 1 for every point that we've got here. Okay, it's incrementing by 1, and what that means is we have our time, our horizontal axis, is not scaled. In other words, it doesn't have units, it's just samples. We don't want that, okay? So how do you fix that in MATLAB? Well, and I realize that this font is really, really small. Let's look at my preferences and see if we can get here. Fonts. Ooh, is out of my, great. So what I just did is I plot example : 2. If you are having trouble with this, we need to back up before this. But what I want to do is I want to put the time on the horizontal axis. So remember the first column. So this represents our first column, right? Our first column was time. And our second column was one of the two. And I'm going to do the same thing. I like the dash dot, dot dash. Okay. Once again, we get this horrible kind of looking thing here. And that's just because of how it's sampled. It's perfectly sampled because it's a simulation. Okay. And now each data tick, if I go and I select this guy, each data tick, if you look, the X is 0.05238, and we can put that into seconds. We assume that that's seconds. Okay, so this is what Multisim gave us. This is how Multisim sampled this. Okay, so let's do one more thing. I'm going to do hold on to hold the current plot. And up arrows are fantastic in Matlab. So I just used up arrow, and I'm going to change this, and we're going to plot another one. And if you look, just as expected, we have the two voltages. One is half of the other voltage, right on top of each other. There's no phase difference, and this is what Multisim has given us. So this is Multisim data. And so you could even do something. You could even do something here and put legend. Multisim channel 1, and then you could say multisim channel 2. Makes a nice little legend for me right here. Okay, you could play with font size on that, make it bigger, smaller, whatever you like. You just through the editing. Okay, so that was great. That gives us our multisim data. Now, the only problem that we have with our multisim data actually is this. There's so much of it, okay? We'll deal with that in a minute, but right now we can just zoom. We can just take this data and zoom down to something reasonable. And even that wasn't reasonable. So that's a little bit more reasonable, right? And there are ways that you can do this through the command line as well. All right, so now we want our Matlab data. Okay, our scope data. And remember that one was a little bit different, but let's hit import data. There's lots of ways to do this, but we're just going to hit import data again. And it's going to open up our CSV, and look, it has all this data selected. Remember, that's our time step is that column, and I just did the unthinkable, but I'll just show you in case you do this, what you do. And so I just selected, I only care about these two columns. Remember, I want it as a numeric matrix, but it's going to go from B3 to C. I don't know. Are there 1,000 there? And so I'm going to take this thing. Yep, there's more than 1,000. There are 1,202. So I'm going to go all the way to the end. Okay. And I'm going to import this as well. So go, it imports it. It imported as new file. It's a 1200 by 2 matrix. Okay. It's not by the way, it's not a coincidence that it's exactly 1200. That happens to do with how the window is open. So if we take a look at this, there's a new variable over here in our workspace. Okay. And I'm just going to say, here's our biggest problem. We don't have a time vector. And so if I were to plot just new file, the first column, okay, and go and look at what happened here and zoom way out. So that's from the scope. that yellow line is from the scope. Well, what happened? Well, it's plotting it per sample. The time scale doesn't match. And this is where we get to the tricky part. I need a time scale for it. It has to have, so if we look at the size of new file 1, it has to be 1200 long, and it has to be spaced by point, let me see, by 5 microseconds. So my dt, my delta t is equal to 5 e to the minus 6. Remember, I got that from here at the very top. They told me that. So this one takes a little bit more work, but 5 times 10 to the negative 6th is our delta t space. And this is the tricky. So this one you just might want to memorize. I'm going to make my time vector, and I'm going to use something called linear space, or lin space in Matlab. Okay, I want it to start at 0. I want it to end at the length of new file 1 times the dt. In other words, this should end at, so 1200 times 5 times 10 to the negative 6 is how long the window is. We'll go back and do that calculation here in a second. And then the last thing I want to tell it is how big the space is, or how many. And then how many is oops, and so I made a mistake. That was a capital. And now we could look at size of tvec. And it's 1200 long, exactly how we expected. Okay, we could even look at tvec from 1 to 20. Okay, and you can tell 0.5. And I made a little bit of a goof up here, like 0.05. And the goof up is, you see, it's not exactly 5 milliseconds or 5 microseconds between each one. Okay, let's fix that. We're going to go back to here, and my mistake is this starts at 0 rather than, we can either start this at dt, so that it starts at 0.005, or we can start at 0 and we could do length of new file minus 1. In other words, we have to go either from 0 to 1299 times dt, or 1199 times dt, or we have to go from 1, or we have to go from 5 microseconds to 1200 times dt. That's a little bit more complicated. Let's look at this now. If I look at the first 20 now these are perfectly spaced. So this is a little bit of math that we're doing. This is tricky. These are perfectly spaced at 5 microseconds. And now I'm going to turn my hold off. I'm going to plot. I'm going to use my wonderful method to do this. Hold on. Plot both of those, and so we should be back. Yes, we're back to this ugly thing. Okay, and now I'm going to plot tvec versus, do you remember what the name of the file is? That's right, new file 1, first column. Okay, and I will do the dot dash. If you look, it just showed up in the background right here. And that was fortuitous that we saw it. And so what we will do is we will zoom in and we'll take a look. What do you notice? Well, first of all, you notice that the real data is noisy, and that's fine. The other thing that you notice is that there's a time shift. Well, dang. Well, there's a reason why there's a time shift. There's no such thing as 0. There's no 0 time that we referenced both of these from. So there's a time shift. We're going to have to account for that if we want these to line up, because the simulation should match what's going on. So only other thing I'm going to do is put on that 4th data plot, and there they are. Okay, so what does this mean for you? Well, At this point, we're probably satisfied that these are both the same except for the time shift. And we'll have to figure out what that is. The easiest way to figure out what the time shift is we're going to pick that point, the maximum point on that dude. Look at the time. And let me see. I think I can do Alt and pick the maximum. It's hard to do the maximum point on these because they're so noisy, but I'm going to pick that one. Maybe it's Shift. Okay, so it's not letting me do a second one. So this one, oh, there we go. So 0.00125 minus 0.001134. Okay, so let's put this in here. Let's save it somehow. My t-diff is equal to 0.001245 minus 0.001134. Okay, so that's our t-diff, the difference in time between the peak to the peak, at least as far as we can tell. Okay, and what do we do with that? Well, the one thing that we can do is I can come up here to this guy, and I forget if it's plus or minus, so I'm going to subtract t-diff. Now watch what happens in the background there. And that lines up just a lot better. I don't know if you saw the green that popped up there in the background, but that t-diff shifted it to the right, to the left. In other words, I subtracted a value off of the time vector to shift it to the left. Okay, and that's exactly what happens. And so then we can also plot the same thing. And now we have a whole bunch of hooey garbage on there, and we can get rid of that. So we can say go back all the way to here. Hold on, plot. That one. So we have the in the background there. You can see that we have the multisim data on there, and then we can plot the last two things. And let's go see what happened here. That looks pretty darn good, and I'm going to focus in on maybe just a couple cycles. So we've got our phase difference pretty much lined up. You can tell it's lagging just a little bit. We could probably get better on our t-diff on that, but that's the basic idea of getting data into this format. It is a little bit challenging, so use this video as a reference for how to import and time align data. Also use scripts. So we'll talk more about scripts in other videos.